Okay guys, so we're talking about lesson 11.2 today, ellipses. So these are the equations of ellipses. So we have one where it's x squared over a squared, and the other one is x squared over b squared. So just pay attention to the fact that a is the biggest. So pay attention when you're seeing a problem like that. The other thing that you need to focus on is the foci. So those are here. So pay attention to that formula as well. Okay, so let's start out with example 1. They want me to sketch the graph of this, and the first thing that I notice is it doesn't equal 1. So pay attention to that, make sure it always equals 1. So I'm going to go through and divide everything by 18 to make that happen. So that's going to give me x squared over 9 plus y squared over 2 equals 1. So because 9 is bigger than 2, this is my a squared, this one is my b squared, so I always just kind of mark that for myself. And then tell myself, okay, well then what is a and b? So a has to be plus or minus 3 if I square root that, and b has to be plus or minus the square root of 2. So when I'm looking at my ellipse, my vertices are going to be, in this case, I'm going to have, because this is with your x, this is going to be a -3, 0, and a 3, 0. And then my b's are with my y, so this is going to be 0, negative square root of 2, and 0, positive square root of 2. So the only other thing I have to worry about is the foci. So over here, I'm going to talk about that. C squared equals a squared minus b squared is how I find that. So I'm looking for C. So I know a squared and b squared. I'm just going to use the squared values instead of using a and b. So I'm going to use 9 and 2. So that means C squared has to be 7, which means C is plus or minus the square root of 7, which is about plus or minus, I'm going to call it 2.65, around in there. That way when I go to graph it, it makes more sense. So I'm going to graph all of those things. So let's start with this one, -3, 0, and 3, 0. And then the square root of 2, it's kind of important to pay attention to what that is. The square root of 2 is about 1.41. So when I go to put that on the graph, I'm not going left or right at all, but I'm going down 1.41 and then up 1.41. So around in there. It's close to 1.5. Okay. So on this one, my x-axis is where my major axis is. My minor axis is this way. So my focus then should be on that x-axis. So plus or minus that 2.65 is going to go on this axis right here. So 2.65 is around in here. 2.65 negative is around in there. So my ellipse is going to look something like this. This is really curved right there. It shouldn't be pointy. So when you're sketching it, make sure you try to round out those corners there. Okay, so it's about like that. All right, so example 2, they want me to sketch a graph again. This is the equation they give me. This one's a little bit trickier. So when I divide by 25, just like I did on that last one, I need to do that. The problem is I can't have a number in front of my x squared. I really got to clear that out of there. So I'm also going to take this and divide it by that top number to get rid of that. So I'm going to divide by 9, and that will cancel that out. Divide by 9, or by 4, sorry, and that'll cancel that one out. So I kind of think of it like that. So this equation would really look like this: x squared over 25 over 9 plus y squared over 25 over 4 equals 1. So what that means for me is, the other question is which of these is bigger, right? So in this case, this is the same. So let's square root it first. I'm sorry. Let's square root it. So if I square root that, this value, I'm not going to say if it's A or B yet because I don't know. But this value is going to be plus or minus 5/3. This one is going to be plus or minus 5/2. So the question is, which of those two is bigger? Well, 5/2 is like 2.5, and 5/3 is 1 2/3. So this one is bigger. That tells me this one has to be A, and this one has to be B. So this was B squared, and this was A squared. Okay. So the points that I'm putting on my graph here are going to be, this is with your x, so this is negative 5/3, 0, and 5/3, 0. And then I've got these two, which are with my y, so this is 0, negative 5/2, and 0, 5/2. And then I need to find my focus points, so my a squared, or c squared equals a squared minus b squared. Okay, so c squared then is going to be 25/4, which was this, minus my 25/9, which was here. I need to make that a little more clear that that's a 4 right there. Okay, so c squared equals, if I get a common denominator and subtract those, I end up with 125/36, which makes c about, remember it's plus or minus, I'm just getting the decimal here, and I got about 1.86 if I square rooted it. Okay, so putting all this on the graph, so I've got negative 5/3, 0, so negative 1 2/3, 0. Same thing this direction, 1 2/3. And then I've got negative 2.5 and positive 2.5. So my major axis is my y-axis this time. And then my c is going to be plus and minus 1.86. So 1.86 would be, I'm going to call it about right here. And then same thing down this direction. And then you can sketch that out as good as possible. That looks about like that. Okay. Example 3 is a little bit different. They don't want me to sketch this one. They want me to write an equation. So find an equation of the ellipse with vertices plus or minus 4, 0, and then this focus set. So the first thing that I would look at, so don't forget that when you're given a vertice, you're given really an x squared over either an a squared or a b squared. So let's say it's a squared, and I'm saying that because I can figure out in a minute which one it is. And then on this one, I know that my c is 2. That's what this plus or minus 2 is. Okay, so then let's look at this setup. So x squared over a squared plus y squared over b squared equals 1. So if this were squared, that would be 16. So this is x squared over 16 plus, I don't know about this one, right, equals 1. But now if I plug this in over here, so remember you've got your c squared equals a squared minus b squared. So I can say this is really 4 and this is really 16. So then I can solve this out. So minus your 16 and then divide by -1. And then I could go ahead and square root this, but to be honest, I just need to finish this equation, which is where b squared is right here. So that would be 12. So earlier, I think I said I need to see if this is A or if this is B. That's not true. If my vertices and my focus are both in that X situation, so remember your foci are always on your major axis. So I already know that those are on my x-axis. So that's where that goes. Okay, so there's that equation right there. So that one I feel like is a little bit easier than having to go through all of the graphing. Okay, my next two. So example 4, they want me to find equations for the upper, lower, left, and right halves of this ellipse. So what I would do, remember to find the upper and lower and left and right, you can just solve for y and solve for x. It's just like with those previous lessons. So I'm going to write this down twice, and I'm going to solve for each of those. So on this first one, I'm going to solve for y first. So I'm going to minus my 9x squared. So 25 minus 9x squared. And then I'm going to divide by 4. So y squared equals 25 minus 9x squared all over 4. And then I'm going to square root. So plus or minus the square root of 25 minus 9x squared over 4. Now, a lot of people are tempted to just square root everything in here because they're all perfect squares. But you can't do that when there's subtraction right here. What you could do, and I could see the back of the book doing this, pull out this as a 1/4. The square root of 1/4 is 1/2. So they may say this. They may say, let me actually put it up a little further. They may just say this, y equals plus or minus 1/2, which is where that 1/4 came from. And then leave that square root of 25 minus 9x squared alone. This is a difference of squares. That doesn't mean you can square root this and square root this. You cannot do that because if you factored this out, one would be plus, one would be minus. So just be careful with that. Don't simplify that any further. If you left your answer like this, I'm okay with that, but if it were multiple choice, they'd probably do this. So same thing on this side, except I'm going to solve for x. So x squared equals 25 minus 4y squared over 9. I'm going kind of fast because I'm just trying to make the video a little shorter. So plus or minus the square root of this. Or again, I can pull out that fraction. So x could be plus or minus 1/3 square root of 25 minus 4y squared. So again, I would probably go ahead that extra step, but if you didn't, I wouldn't count it wrong. Okay, last one. Sketch the graph of this. This is kind of the doozy one. Anytime they give it to you in this format, it's not factored out correctly. We need to complete the square. So I'm going to put things together that go together. So I've got a 16x squared and a 64x, and then something that I'm going to add on, plus my y's. I've got 9y squared minus an 18y plus something, equals, I'm going to add my 71 over here. So it's on that side. Okay, so then I'm going to think about how can I complete this square, but I noticed immediately that I've got common factors here. So why not take 16 out of this and complete this square when it's a little bit smaller? Like that. Same thing with this one. Take a 9 out and it's going to be a lot prettier to complete the square with. We just have to be careful over here with what we add on. So if I complete this square, I'm going to divide this by 2, I get 2, and then square it, you get 4. But when I put it over here, I really have a 16 times a 4. So plus a 16 times a 4. Same thing with this one. Divide it by 2, I get -1. Square it, I get 1. But I'm really doing 9 times 1. Okay. Then that gives me, I've got my 16, and I've got an x squared plus 2, x plus 2 squared. Plus I've got my 9 and my y minus 1 squared. Equals, when I put all of this together, I get 144. So now this piece right here, this and this tells me my center of my ellipse is not going to be at 0, 0 this time. This time it's going to be at, let me write it down here, my center is going to be at -2, 1. So I'm going to go ahead and put that on the graph right there. Okay, then I'm going to go through and divide everything by 144 because this has to be equal to 1. And then also I have to realize this can't have a number up here, so I got to get rid of that. In this one, it divides out nicely though. So I end up with x plus 2 squared over 144 divided by 16 is 9, plus y minus 1 squared over, this one would be 16, equals 1. Okay, so that tells me, so remember, look at the size of these two. This one is bigger, so this has to be your a squared, which means your a has to be plus or minus 4. This is my b squared then, so b has to be plus or minus 3. So when I'm looking at my values over here, so my axis is going to be, my major axis is going to be my y. So that means I've got a up 4 from this. So be careful where you're going from. We've been going from 0, 0 and just going up 4 and down 4. Now I have to go from that center point up 4 and down 4. So 1, 2, 3, 4 would be like a little bit higher, like right here. And then 1, 2, 3, 4 here. And then I've got 3 going this direction, 1, 2, 3. And 1, 2, 3. It'll be right there. So I've got this ellipse. It looks very circular in this case. It's because they're pretty close to each other. I'm really bad at sketching these guys. It's not too bad. Okay, so that's a nice sketch of that one. I could have written out these points, but I didn't. I didn't really worry about it, but it could be, so what I should have done is said I'm at 2 already, -2 already, and then I'm going to subtract another 3 from that. So I'm at -2 and I'm going to subtract a 3 from it. And then on the other one, I was at -2 and I'm going to add a 3 to it. So that would be those 2 points. And then same thing with this one. I could say I'm at 0 on that one, but my y value, I'm already at 1. I'm at 1 and I'm going to subtract 4. And I'm at 1 and I'm going to add 4. So that gives me those points.